Okay, so the second part of lesson 2.2 talks about velocity and average velocity and instantaneous velocity, and we're going to use the derivative in order to find velocity. So here's what we want to go over. Remember, a derivative shows the rate of change. So if velocity is the rate of change, or how fast our position is changing, to find our velocity, since it's the rate of change of position, doesn't it make sense that we would take our position and find the derivative of it? Okay, so let's talk about some things first. Things you must know. So you need to either underline this or highlight it, something so this stands out. First of all, velocity can be negative, zero, or positive. If you have velocity that is negative, an object is going to be moving to the left or it's going to be moving down. And you'll see examples of that here in a little bit. Velocity can be zero. If a velocity is zero, then that means the object is at rest or it's not moving. If the velocity is positive, an object is moving to the right or it's moving up. Okay, the speed of an object is the absolute value of its velocity. Speed will never be negative. Okay, the one equation that you're going to see a lot, and if any of you have taken physics, you've already seen this equation, the position of a free fall object. So for example, if I'm standing on top of a building and I just let something go, I don't throw it down, but I just let it go. So under the influence of gravity, and we're going to neglect air resistance, can be represented by this equation. Now, I know it seems weird, but S always stands for position. They don't use a P usually for position. They'll usually use S. So anytime you see S, they're talking about your position. Is 1/2 gt squared plus v sub 0 t plus s sub 0. So here's what those things stand for. S sub 0 is my initial height or my initial position. Remember, S is position. V sub 0 is the initial velocity. So if I throw something down, that would be my, however fast I throw it down, that's my initial velocity. G is the acceleration due to gravity. So it's the Earth's pull on something. On Earth, it's always going to be, this number right here will always be substituted with either negative 32 feet per second squared or negative 9.8 meters. Okay, so depending on what your problem's in, feet or meters, you're going to use one of these two numbers. All right, so we're going to come back to that equation here in a little bit. Okay, given a position function, find the average velocity. So average velocity can be found by this equation. Remember what this means? The change in S, or the change in my position, over the change in time. Okay, that's what we're going to use anytime we're asking for velocity. The change in position divided by the change in time. And remember I put right here, just remember S sub t or S sub t is my position function. So let's look at example 1. Let my position be negative 16t squared plus 50, where t is in time in seconds, and S of t is feet. What is the average velocity on 0 to 1? So from 0 to 1 seconds, I want to know what is the average velocity. So here's what I'm going to write every time. Remember, it's the change in my position over my change in time. So how would I do that? I'm going to take my position function and I'm going to plug 1 in it. Then I'm going to take my position function and plug 0 in it. That's going to show me the change in my position, so with my position at 1 minus my position at 0 seconds, over 1 minus 0, my change in time. So what does that mean? S of 1 means to plug 1 into this equation. When I plug 1 into that equation, I'm going to get 34. So I have 34 minus, when I plug 0 in here, I get 50. All over 1 minus 0, which is 1. So 34 minus 50 is negative 16 over 1. So my answer is negative 16. Now we always want to put units on this. I'm finding average velocity. So velocity, and I'm in feet and seconds. So it's going to be negative 16 feet per second. Remember, velocity can be negative, positive, or 0. In this case, whatever this was either moving down or to the left. Okay, let's look at another example. Example 2. If a billiard is dropped from a height of 100 feet, its height s at time t is given by the position function s of t equals negative 16t squared plus 100. S is measured in feet and t is measured in seconds. Find the average velocity over each of the following time intervals. So I have this ball. Okay, I'm dropping it from a height of 100 feet. I want to know between 1 and 2 seconds, how fast on average is it falling? The average velocity. So change in my time, or change in my position, over my change in time. So when I plug 2 into this equation, I get negative 16 times 4 plus 100. When I work that out, you should get 36. Now I'm going to take 1, plug it into this equation. So when I take 1 and plug it in, this was 36. This should be 84. So 36 minus 84 over my change in time. 36 minus 84, negative 48. My units would be feet per second. So let's see if that answer makes sense. First of all, I got a negative answer. So does it make sense that if I'm on top of a building and I drop a ball, that its velocity is negative 48 feet per second because it's dropping down, it's going down. So remember, negative velocity means it's moving down or to the left. All right, so between 1 and 1.5 seconds. So I'm changing my position, and I always put my largest number in first. So s of 1.5 minus s of 1 all over my change in time, 1.5 minus 1. So I'm going to use the same equation over here. This time I'm plugging in 1.5 and 1. So you might have to use your calculator for that. But when I plug 1.5 in place of my t, you should get 64. When I plug 1 in, I get 84 again. So I have 64 minus 84 all over 1.5 minus 1, so that gives me 0.5. When you put this in your calculator, you should get negative 40. Again, I need units, feet per second. And again, it makes sense that I have a negative answer because I dropped something down, so it's going down. My velocity would be negative. Okay, example 3. At time t equals 0, a diver jumps from a platform diving board that is 32 feet above the water. The position of the diver is given by, it gives me my position function, where s is measured in feet and t is measured in seconds. When does the diver hit the water? So let's look at what we have first. Here's my diving board. Okay, I know that this is 32 feet. Oh, I don't know what happened. There we go. Above the water. Alright, so here's my guy. He's going to jump off and he's going to go down and hit the water. Okay? So the first question says, when does the diver hit the water? So here's my position function. This is my position. Okay, right now, right here, here's my position, which goes with this equation. Does it make sense that he's going to hit the water when my position equals 0? Okay, at 0, his position is 0. He's going to hit the water. Okay, right now, this equation right here goes with this position. If I want to know when his position is 0, I'm going to take this equation, set it equal to 0, and solve. So I have 16t squared plus 16t plus 32 equals 0. Now this is a quadratic equation. I know that because it's squared. There's lots of ways we can solve quadratic equations. I can factor, I can use quadratic formula, I can graph it, see where it crosses the x-axis. So on this one, you can either use your ACT program and use quadratic formula and plug it in. This one is easily factored though. I'm going to show you how I would factor out. I'm going to factor out a 16. Oops, I forgot my negative. So I'm going to factor out a negative 16. So that's t squared, and then that's going to make this negative and negative. So minus t, because I factored that 16 out, minus 2. So now I can factor that, negative 16. I need factors of 2 that when I subtract them I get 1. So t minus 2, t plus 1. So t has to be 2, or t can be negative 1. Okay, so let's think about what they're asking. They want to know at what time did my diver hit the water. So I have two choices. It's either at 2 seconds or negative 1 second. It doesn't make sense to have negative time, so it's going to hit the water at 2 seconds. So now it says, what is the diver's velocity at impact? Okay, well first of all, I need a velocity equation. I don't have one. All I have is a position equation right here. But we know that velocity is the rate of change of my position. So if I talk about anytime I'm talking about the rate of change, I can find the derivative. So when I find the derivative of this position function, it's going to give me my velocity equation. So my velocity equals, I'm finding the derivative of this using the power rule. Bring down my 2. Negative 32t, subtract 1 from your exponent. The derivative of 16t is 16. The derivative of 32, since it's a constant, is 0. So this is now my velocity equation. And I got that by finding the derivative of my position. So it says, what is the diver's velocity at impact? Here's my velocity equation. I know he hit the water at 2 seconds. So doesn't it make sense? I want to know the velocity at 2 seconds because that's when he hit. That's when his position was 0. So I'm going to plug 2 into my velocity equation. Negative 32 times 2 plus 16. Negative 64 plus 16. And that's going to give me negative 48 feet per second. And again, it makes sense that I have a negative answer because my diver was falling down. So it should be a negative velocity. Okay, example 4. A ball is thrown straight up. Oh no, I'm sorry. A ball is thrown straight down from the top of a 220 feet building with an initial velocity of negative 22 feet per second. What is its velocity after 3 seconds? Okay, well the problem with this one is they didn't give me any kind of equation to start with. So when that happens, remember that equation that we had at the very beginning? This one right here? That's the equation I'm going to use. Okay, so let me write that down at the top here. All right, I'm going to use my position equals 1/2. Now I'm either going to use 32 feet per second for my gravity, negative 32, or negative 9.8. Since I'm in feet, let's go back and look. Since I'm in feet, I'm using negative 32 feet per second. So negative 32 t squared plus v sub 0 t plus s sub 0. That's the equation that was on your first page. So now let's plug in the numbers. It says from the top of a 220 feet building. That's my initial position. That's where it starts. It says my initial velocity is negative 22. That's my v sub 0. So down here, I'm going to go ahead and plug those numbers in. So I have s of t equals 1/2 times negative 32. It's negative 16. Negative 16t squared plus my initial velocity, negative 22 feet. So I'm going to change that plus to a minus. So minus 22t plus my initial position, 220. So now I have an equation I can work with. So it's asking for the velocity. The problem is I don't have a velocity equation. But if I know a position equation, I can get my velocity equation by taking the derivative. So the derivative of this, bring down my exponent, negative 32t, derivative of 22t, 22. So I have my velocity equation. They want to know what is the velocity after 3 seconds. So I'm going to take 3, plug it in. Negative 32 times 3 minus 22. When I simplify that, I get negative 118 feet per second. My velocity is negative because the ball was thrown from the top of a building and it's moving down. Okay, part B. What is its velocity after falling 108 feet? So I'm good. I already have a velocity equation. That's good. I'm going to change colors here. Okay, so here's the thing though. It started at 220 feet tall, right? I want to know after falling 108 feet. So where is it at? If it started at 220, after it fell 108 feet, it's actually 112 feet above. That's its position, 112. It's not my answer yet, but we're going to use that. So I want to know, when is the position 112? Well, how would I do that? I have a position equation. I want to know when this is equal to 112. So I'm going to take this equation, set it equal to 112. Negative 16t squared minus 22t plus 220 equals 112. I need to set this equal to 0, so I'm going to subtract my 112. Negative 16t squared minus 22t, subtract 112, and now I get 108. Okay, so I have a quadratic equation again. I need to solve this. Solve it by quadratic formula, factoring, whatever. I would use my ACT program for this. ACT program, and go to my quadratic formula. When you do that, you're going to get two answers. T equals 2 or T equals negative 3.375. So now I have to choose which one makes sense. I'm talking about time. I can't have negative time. So I'm using 2 seconds. Now look and see what they're asking. What is its velocity? 2 seconds is not a velocity, so I'm not done. But I know at 2 seconds, it has fallen 108 feet. So now I'm going to take my velocity equation and plug 2 in. So here's my velocity equation right here. Negative 32t, but my t is 2, minus 22. When I simplify that, I get negative 86 feet per second. So at 108 feet, after falling 108 feet, which it took it 2 seconds in order to do that, it's falling at a negative 86 feet per second. Last one. During the first 40 seconds of a rocket flight, the rocket is propelled straight up so that in t seconds it reaches a height given by, here's my position. So part A, what is its position at t equals 40 seconds? So they're just wanting to know, after shooting up, at 40 seconds, how high is it? Well, this is easy. It's asking for position. Here's my position. They're saying plug 40 in place of my t. So s of 40 equals 40 cubed divided by the square root of 10. And when you put that in your calculator, you get 20,238.577 feet. You will always go 3 decimal places. Makes sense that I have a positive number because it's shooting up. Makes sense that's a pretty big number. If it's a rocket going up, after 40 seconds, it's over 20,000 feet high. Part B. What is its average velocity from 0 to 40? So remember, average velocity is my change in position over my change in time. So I say s of 40 minus s of 0 equals, over 40 minus 0. So I need to plug 40 into this equation. Okay, well when you plug 40 in, we know what we got, we just did it. That number minus, when I plug 0 in, I get 0, all over 40. When I divide that out, I get 505.964 feet per second. It's going pretty fast. 505 feet per second. It's a positive number because it's moving up. Part C says, find its velocity at t equals 40. Problem is, I don't have a velocity equation, but I can get one. I can get one by taking the derivative of this right here. So look, the derivative says, power rule says, bring down your exponent. I'm going to bring down my exponent. My square root of 10 stays there, and I subtract 1 from my exponent. So that's my velocity equation. Now it says find its velocity when t is 40. So now I'm going to plug 40 into that. 3 times 40 squared divided by the square root of 10. When I put that in my calculator, 1,517.893 feet per second. So at that particular time, when t is 40, it's going a little over 1,500 feet per second. Okay, I think that was the last one. All right, I will see you tomorrow.